Today class will be looking at a uniformly accelerated motion problem that has two separate segments. Let's take a look. A motorcycle ride consists of two segments. During segment 1, the motorcycle accelerates from rest at 2.6 meters per second squared for 120 meters. Immediately after segment 1, segment 2 begins and the motorcycle slows down with an acceleration magnitude of 1.5 meters per second squared for 4 seconds. What is the displacement of the motorcycle for segment 2? You can look here and see in the graphic that I borrowed from our book that segment 2 happens immediately after segment 1. And so what you need to do is treat this as two separate problems and two steps to get us there. Remember that the uniformly accelerated motion equations only work when you're under a constant acceleration for a given time period. So we have a constant acceleration here, but for each separate segment. So segment 1, you can see that we were actually accelerating from rest, speeding up with a constant acceleration, and then during segment 2, we're actually slowing down with a constant acceleration. Now, you can see in the graphic that the arrow is backwards or in the opposite direction that we were traveling. And again, we know that we're slowing down, so that acceleration during segment 2 has to be a negative 1.5 meters per second squared because our velocity is in the positive direction. So the direction that we're moving, we're given as a positive displacement, and so we're going to define that direction that we're moving in as the positive direction. All right, so what we need to do is, after we've kind of read through the problem, is actually go back through and look at it and try and identify the variables that we know. So for segment 1, we're told that we start from rest, which means that our initial velocity is going to be 0 meters per second squared. 0 meters per second. We don't really know what our final velocity for segment 1 is. We're not really told that. We're told that the acceleration for segment 1 is 2.6 meters per second squared, and that it happens over 120 meters. And we're also not told what the time period is for segment 1. But we do remember that segment 2 starts immediately after segment 1, so that final velocity from segment 1 is actually going to also be our initial velocity for segment 2. We don't know the final velocity at the end of segment 2, and we're told that there's an acceleration of 1.5, a magnitude of 1.5 meters per second. But again, we know that the motorcycle is slowing down in segment 2, so it must be in the opposite direction that I'm traveling, which we're defining as the positive direction. So the acceleration 2 is negative 1.5 meters per second squared. The displacement for segment 2 is actually what we're trying to solve for, and the time for segment 2, we're told, happens for 4 seconds. So when you're looking at this, what we have to do then, now that we have identified what we're trying to solve for, we're trying to solve for displacement during the second segment, but we only know 2 variables out of the 5. And remember, we need to have 3 variables to be able to use the UAM equations. And so we need to find the end velocity of segment 1, or the final velocity of segment 1, so that we can go ahead and actually use that in segment 2 to get to the displacement in segment 2. So again, I have the 4 uniformly accelerated motion equations here. You want to make sure you have them handy anytime you're solving these problems. And I want you to look at, we have 3 known variables for segment 1. Can you determine which equation we want to use to solve for the final velocity of segment 1? Well, what you need to do is identify first the equation that has final velocity in it and also does not have time. So which equation has final velocity but does not have time? So it's actually this third equation that we have identified here. It's your final velocity squared is equal to initial velocity squared plus 2 times the acceleration times displacement. So let's go ahead and rewrite this equation with the variables that we need for segment 1. So it will be final velocity 1 equals initial velocity 1 squared plus 2 times the acceleration 1 times the displacement for segment 1. It's rearranged here by taking the square root of both sides so we can have isolated final velocity 1, and then plug in our variables. So we've plugged in our initial velocity of 0 meters per second and our acceleration of positive 2.6 meters per second squared and our displacement of 120 meters. And we find that the final velocity for segment 1 is 24.98 meters per second. So what we can do then is go back to your defined variables, and let's go ahead and plug in this answer that we solved for, which is the final velocity of segment 1 and now our initial velocity for segment 2. This will enable us again to have these three separate variables that we know. And from here we can try to identify which one of the 4 UAM equations we want to use. Take a look at them and see if you can decide which one we think we should use to solve for the displacement 2. Okay, so just like before, we need to find displacement 2 in one of these equations, but it can't have the final velocity in. And again, is there an equation that's actually set up to solve for it for displacement? There are 2 of them, and one of them does not have final velocity in it. So it's the second equation here that we're going to use to solve for the final displacement during segment 2. So again, rewrite the equation in variable form for the variables that are given for this problem here. So for segment 2, the displacement is going to be the initial velocity 2 times time 2 plus 1/2 a, or acceleration 2, times the time for segment 2 squared. Plugging in all of our variables, the 24.98 meters per second, which was our initial velocity and final velocity from segment 1, times the 4 seconds, plus 1/2 times the negative 1.5 meters per second squared for the acceleration during segment 2, again happening for 4 seconds, and we're going to square that time 2. And that gives us a displacement during segment 2 over those 4 seconds of 87.92 meters, or using 2 significant figures will give us 88 meters. Thank you, and I'll see you soon.